let's go through that. It says here, lines, so there are two lines, lines L and M are drawn on the square grid, right? And you're seeing them. Looking at your grid, you're looking at the lines. They're already. All right, let's see what they're asking. It says write down the coordinates of the x-intercept. Well, knowing the meaning of the word is important. X-intercept. An intercept is where something crosses something. So the x-intercept will be here, right? That's the x-intercept for the line L. Crosses the x-axis. They want us to write down the coordinate, so I could simply say the coordinate, and don't make a mistake here, is when you name the x value first, followed by the y value. So I will highlight, try to show you. The x value here is 6, yeah? And the y value, this is where y is 0, all right? So 6 means 0 here, so this is 6, 0. So they're giving you 1 mark to write 6, 0 here. So you do that, you move on. So don't overthink, don't overstress. Read, take your time, flow through.
Sir,
Go ahead, I'm listening.
you say when you're in the coordinates, you must write the x-axis number first before the y?
All the time, every time.
Okay, sir, thanks.
All right, very good. Coordinates are written like this, x, then y. Good. And just for a teachable moment, I'll highlight something. If this is the point, this is the x number, number 4 here, and this is the y number. So we'll call this 4 meets 3. You have to read this one, then that one. So that is how the world has already set up coordinates. So you can't do otherwise. People will have wrong understanding. So for conventional purposes, we have to embrace that, right? All right, we want to know the y-intercept for M, y-intercept for M. So the line M, we're seeing it. Let me highlight M here. So the y-intercept is right here. And is the coordinate the one? Same principle. So the x value here, this is 0 for the x, and this is -2 for the y. So don't mix up the ideas. All right, so for this one, it is 0 meets -2. There it is. All right, so let's write that. 0 meets -2. You get your mark and you're gone. All right, so they are testing, right? Let me take myself off the screen for a minute. I'm going to close my camera.
Sir, can go back a little bit.
I will. Give me a minute. I will. Hold on. All right. Let me minimize this. All right. Put this right there. Very good. You're seeing now? Are you okay? Kevin?
Yes, sir.
All right. All right. So let's call the questions. The next question says here, the equation of the line L is x plus 2y minus 6 equals 0. Find the value of k given that the point 9k lies on the line. I want you to note a very important idea. If I have a line and the equation of this line says y is equal to 3x minus 1. If I find multiple points on this line, multiple, doesn't matter how many I want to find. If the points are on the line, if I should take the x value, let us say that, I'm just making up something just to discuss, and then I've got to do what we do. Let us say this is 1, 4, this point here. This is an x and that's a y. If I should put number 1 where the x is and work out the maths, it's going to tell me the y value. That's what the equation of the line is equipped to do. As long as the point is on that line, if you take the x value and plug it where x is and work out the maths, it's going to tell you the y value. And then vice versa. If you take the y value and put it in and try to work it out, you can find the x value. As long as it is on the line, you'll get the truth. If it is not on the line, you won't get the truth. So they are telling us now that, hey, this point is on the line.
Sir,
I'm listening. Go ahead. Speak.
go back a little bit up, check and write off the equation, sir.
It is on. This is the equation.
No, sir, the number A, sir, A.
Oh, you're not writing an equation. What equation are you writing? You're sure there's no, we didn't get any equation up here.
Oh, okay, sir. I thought there was a
No.
equation, right? Okay, sir.
No, man, this is it. So the question is here. The equation of the line L is, they told you, this is it. Now, they had said that the point 9K is on the line, and you're supposed to find K. All you're going to do is to do what we just said. I'm going to take the X value and substitute it. See them there? So then, this is the equation for the line. It says X plus 2Y minus 6 is 0. I can use this to find points that are on that line. So you see the 9, I'm going to put the 9 for X, and I'm going to put K for Y. Because since they asked me to find K, I'm going to put K there so that when I'm working it out, I'll see K coming out. So we're going to substitute. So in other words then, 9 plus 2 times Y, but Y is K, so I'm going to put K. Minus 6, and this is 0. Very straightforward setting up. See there? Very straightforward. Substituting these. Then you solve for K. Solve for K, man. We could just relax, put together our numbers. 9 minus 6 will give a positive 3. Right? So the 9 with a minus 6 is a 3 right there. And this is equal to 0. We're almost there. I need to find K. So I would want to subtract 3 regular from both sides. So I'll have 2K equal to negative 3. Then to find K, I divide by 2. So K is equal to negative 3 over 2. So this is rest on the fact that if a point is on the line, you can substitute one known value to get the other unknown. Just like that. Not a problem. Don't overthink it. Just learn that you are able to do that. Make a note. And if they should send a question like this, we don't know, you can approach it like this. What it means, you know, if they claim that this is on the line, they could ask the question another way. You can test to see if points are on a line. Because if I have a point that is 2, 5, and I plug in 2, and I did not get 5, it means that it's not on the line. You need to understand that's what it means. That's all. All right, let's look at the next piece of the question. Daily, we are at 4. 4, 5, 6, those papers. All right. Find the equation of the line M in the form y equal to mx plus c. So in other words then, can you let the y be by itself? That's what they're asking. So let us write back what it is. It is x plus 2y minus 6 equals 0. But they are saying it's m, it's not m. This is the L1. Let's go for m, not that one. M. Let me mark it where it is. Find the equation of m. All right, let's go for m. Looking at m, guys, m. All right. Pay attention to this one, M. Now, whenever you're going to do the equation of a line, you need two things. We need gradient, and you need, so gradient is what we call M, and you need y-intercept, and we call that C. Luckily for M, the y-intercept, see here, it's -2. So we already know that. We know that it's -2. The line crossed the y-axis at -2. So all we need to do is to work out M. Now, you can do more than one things to work out M or to see the value of M. You could look at this. If you're able to pick off a very good right angle triangle, look where the points I'm making there. Look at this. I'm able to see a good enough right angle triangle. See there? There are many. See even one more here. See another one here. You see how many of them are there? I mean, and I'm referring to, so I don't need so many, you know, I'm just showing you that it's all over the thing. So I'm just picking one, and you can pick bigger ones. Look, see a big one here? See there? I only need to pick one. I'm just going to use the two of them to show you that you get the same answer, but I only need one. So let's take a look. When you can pick off triangles where you're able to see the vertical and the horizontal sides clearly. For example, I am seeing that the vertical side here is 2 units and the horizontal side here is 1 unit. Then remember that gradient is equal to rise over run, which is your vertical side over your horizontal side. So the gradient in this case is 2. Let us say that I never saw that triangle and I saw a bigger triangle. Check the big one. This side length is 4. Check it, it's 4 units long. And the short one down here is 2. The vertical, horizontal, vertical is 4, horizontal is 2. So if you were working it out with those numbers, vertical 4 divided by horizontal 2, I still get the same answer. The gradient is 2. So now I'm saying that you're able to do those, man. You can pick up those easily along the way. So then there is no big working out for this. The gradient is 2, the y-intercept is -2. So M is 2, the y-intercept is -2. I could write it in this format by saying y is equal to, instead of putting M now, I'm going to put 2 with the x. And instead of putting the C, I'll put the number for it. That's it. That's what they wanted to do for that question. So it's y equal to 2x minus 2. And you're done with that. Any question pertaining to that? All right. Let's continue looking at more. Show by calculation that line L and M are perpendicular. Now, this is something that you need to make note of. This. When lines are perpendicular, there is a specific thing that happens. I will write it for you because I want you to make note. So I'll write it for you. When lines are perpendicular, the product
The same, sir.
of, give me a minute, the product of their gradient is -1. Jody, Rodney, what were you saying now? Listening now.
No, sir, I thought it was the other one. It's okay.
Okay. Oh, I just realized what you said. You said they are the same. Okay. So when lines are perpendicular, the product of the, this there doesn't spell right. The product of their gradient is -1. No, that's not the answer. That is something that I'm telling you, that this is what you want to show. So this is notes, because they never asked you that, but this is something that you need to know. No, we're talking about, so let me call them line L gradient and line M gradient. We need to go for them, but we know one already. Line M gradient is 2. We just saw that. So we need to know what is line L's gradient. So we know the gradient for line M. See it here? It's 2. So we're going for line L. So we want to find it. Let me clear this diagram again. Clear this up properly. All right. So for line L, the thing is now you can calculate it if you want. See here? Let us say, can we look at a counting method? So let us look at a calculation method, please. So this was a 6, 0 here. And you will know that this is a 0, 3 here. I'm just saying. So let me do another method now. We're not counting. And you have to bear in mind the shape of the line tell you if the gradient is positive or negative. Please note that. All positive. So let me just say this again look at this, just for notes. All positive gradients, the lines are going uphill like that, uphill. Those gradients are always positive. But if you see a line that's set like this, remember that the gradient is always negative. So these are negative gradients. It's like you're going down a hill from left to right. And this one is like you're going up a hill from left to right. So you want to note that. So in this question, you could see that one is positive and one is negative, right? So let's take off this. So M, here are the points. We can label them X1, Y1, X2, Y2. The gradient is Y2 minus Y1 over X2 minus X1. Y2 is 0 minus Y1, 3 over X2 is 6 minus X1, 0. We'll get negative 3 over 6. And when you cancel it down, you get negative 1 over 2. Negative a half. So the gradient for line L is negative a half, which is the regular working out that you know, finding gradients. This is the formula. They're not going to give it to you. You have to know it for yourself. Find 2 points that are on the line, label them, and then you substitute. You get this. The fact that you get this, then you can prove the point to them. Let's go down there to prove the point. So let's write it. So the gradient for L is negative a half. Now, when they said show by calculation, they want you to do this that I'm showing you. So then this says the product. Product means to multiply. So this is saying if I multiply, I should get negative 1. Check it out. That's the proof. So whenever they're going to ask you to prove the perpendicular lines thing, you just need to have the gradient of the 2 lines. If you multiply them, you will always get negative 1. Always. And that only happens if the lines are perpendicular. If they are not perpendicular, you don't get that. So be careful, right? Careful. All right, so that's the proof. Can we now look at the next part of the question? Can we go?
Yes, sir.
Bring it down back a little bit, please.
All right,
Down,
you're writing
down,
up
down, no, down.
like this?
Yes, sir. Right there. Don't move.
You want me to go more?
No, sir. That's all right. You can go, sir.
All right. Now let's look at this part. It says line, we're still under the same thing, right here, the E part. It says Line L and line M represent the graph of a pair of simultaneous equations. So you see, simultaneous equation using, very important, using the graph, not by calculation, write down the solution of the pair of simultaneous equation. They said using the graph. So you see, anybody who want to try to solve it, it's not going to work. They don't want to do that. They said using the graph. So the only thing is you need to understand by looking at a graph and you see lines on it, what does the solution is? What is the solution when you're looking at graphs? Guys, whether you're doing simultaneous any graph, the solutions would be when the two graphs cross, as long as they cross path, like right here. This is their solution. So you need to make a note of this coordinate. That coordinate there is when 2 meets 2. This is an X and this is a Y. That's the solution, you know? You just need to look. Everybody can see where 2 meet 2 right there.
Yes,
Where the
sir.
2 line cross path. So I just want you to understand, and this should be a 1 mark question. If it is there, if the mark, see there is 1 mark, because they would know that there's nothing to do. So you look, you get the coordinate 2, 2. And it means that X is equal to 2, Y is equal to 2. That's your solution. You're done. So you look and you see it, you write it down and you move. Right? I remember I said to you, keep the point system. You'll know when there's a little working needed from when you snap your finger for the answer. All right? Let's continue. Let's continue.
Sir,
All
go
right.
back to the plate.
You speak.
You can go ahead now.
All right. So look at this one now. It says the cumulative frequency curve below shows information about the times taken by 200 students to solve a math Olympiad problem. So you see the cumulative frequency curve. So for some of us, we looked at this in statistics and we did it. We learned to interpret it. Here is a question. All right. So we're dealing with 200 students. Question says, using the cumulative frequency curve shown above, find an estimate for. So you read the questions now. Some 1 marks, so we can pick it up easily. The number of students who took more than 50 minutes. All right, I could do this a neat way, or I could just use my free hand. I hate using my free hand, so I'm going to have to just, give me a minute, let me just do this the right way, please. I just need to have the graph more than 1 time. All right. I'm going to bring it to the other screen where we can use some lines that are more appreciated, you know? All right, let's go for it. All right. I'm going to put another one just in case we might need another one to use and another one.
Sir, before you continue, what was the answer for question E?
Question E, 2, 2.
Okay.
All right. So we could switch between the question. So I'll keep that on screen. So we want to show that the number, they asked us to show this, the number of students who took more than 50 minutes. More than 50 minutes. As you could see, the minutes is on this axis and the number of students is on this axis. So more than 50 minutes means that you're going to come where 50 is, right there, and you're going to do something with it, right? So you're gonna have to take a ruler. From my perspective, I take a line, and I'm going to draw a line from 50. When draw a line from 50, guys, remember how it goes. Hold on, touching the wrong things here. I'm going to draw a line from 50. And you're going to draw it until it touches the curve. So you take a ruler out and you do this. And the moment it touches the curve, you stop. Don't go through as it touches it, because you're going to be getting the answer on the other side now. So as it touches it, you stop. And then you take this and draw another line, go across to the other axis. Like that. Take your time and you draw it. And what I like about these interpretation, everybody will have the same answer. All right? Everybody have to have the same answer because CXC already print his graph. So now, we now can't just assume what number is here. And this is why whenever we're doing the scaling, we have to take the time out to understand where is this, right? Now I need to know what these actually mean. I need to know, I can't just guess it. So I can find a systematic way of finding out, man. See it there? I'm blowing it up bigger for you, right? So the first thing you need to do is to see how many units between this, how many units? And you're gonna realize, oh, that's 20 units. Of course it's 20 units. And then you can divide this up by how many equal parts. 1, 2, 3, 4, 5. So it was split up into 5 equal pieces. Divide it by 5. 5 into itself, 1. 5 into this, 4. So it is telling me that one of those lines, one line is 4 units, which means if we're counting by 4 from every little thing you see. So if this is 180, 184, 188, 192, 196, 200, and it makes sense. So you could see that we are at 196. This is 196. Guys, that's not the answer, though. That's not the answer. No, and this is where a lot of people make error. That's 196, but is that the answer? That's a different thing. Let us read the question. The question says, we want to determine the number of students who took more. So 196 is the marker. More. That means we need to go over 196. Those who took more than that, more than 50 minutes, so go back. More than 50 minutes means that you're going over this section, over. So you're going to have to say, oh, 200 minus 196, you know. The little between this is 4 people. So that's why you have to work on this. So when you get it, you don't run with it until it's 196. Understand the context. They did say over, so you go on top, right? And if they said less than, you go beneath. So it's a big difference. You have to relax, come up with your responses. So in this case, it's going to be 200 minus 196, and the answer is 4 students. We really want to make sure that we understand our context, right? 4 students. Now, for the next question, it says the median time to solve the problem. We need to know what the median is. Our median is what we classify as the second quartile. We call it Q2. And we all know that it is 50% of your sample. 50%. Now, you're going to have to use your understanding. For example, let's go back to this. We need to understand now, we need 50% of the sample. How do you know the samples? The sample is from the question. It's 200 in this case, see there? So there are 200 students. So 50% of 200, everybody know that it's 100. 50% is half. The thing is though, the answer is not this. This is gonna help you to find the answer. That is where a lot of times the mistake is being made. That's not the answer. Normally, if you start on the y-axis, the answer is on the x. If you start on the x-axis, the answer is on the y. I hope you guys start seeing, because you have to interpret the thing through the curve. So we're gonna have to take that 100. And what we want to do is to take the 100, and we're gonna draw the line until it touches the curve. The moment it touches the curve, that's when we are going to have to say, okay, it's there, touch the curve right there. So now I see where it touched the curve. I need to take that down. And you see, I am not telling you, that it's always gonna.
Sir.
Yes.
How did I get the 20 units up at top?
Oh, okay. I said it, you know, you probably never hear. You can look and see it, because what you're doing is a graph is uniquely designed. 100 to 120 is 20. 120 to 140 is 20. 140 to 160 is 20. Agree? Agree? Agree?
Yes, sir.
So we wanted to know what these little lines are. So we take a gap and work it out. We took a gap, find out how many units for that gap, how many equal space it divides into, and it's going to help us to know what one little line means. See that? It works every time. So you don't have to guess it. All right, so that is something that we have been practicing for a while. All right, let's go. All right, back to the question now. Here. So then I'm going to write median on this so that you could see what we're doing. This is the median question. And it is what we call Q2, and it is your 50% mark. Now you need to interpret this. And you see where it come down in an empty space. You have to find out what number is there. Again, the person that just asked the question, here is an opportunity again to find out what these little lines mean. Over time, you can pick up faster, you know. So a lot of times when I'm working with you, I try to give a general understanding, but you will learn faster and pick up faster over time. You will agree that this is 35. It's the middle, right? And then you could see from 30 to 35, that's 5 units. You know? So 30 to 35 is 5 units. So this one is straightforward. So you can see that they're counted by 1. 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Oh, they're counting by 1. You could see that where we are though, that line that I have that came down, it is between 32, 30, what, 30, 33? Between 33 and 34? 33 you have? Oh, 33 flat.
33.
All right, let me look at mine. Let me zoom up mine. Let me zoom up mine. Let me zoom it up. Because remember, I am on this thing here. Oh, all right. So, let me zoom up mine because let me zoom it up. So you see that? You would have a better, all right. So 33 may be the answer because mine passed it. Everybody can see that this look like it barely passed it, don't? Kind of. If I zoom it up, kind of pass it. All right, but you would have a better understanding. Remember, you have the thing printed. All right. So when mine pass it, I wouldn't see it, you know. So technically, it look like it's 33. Let me fix this. So you might be seeing 33. Let me take off this line. Let me bring this back a little bit. All right, a little bit, right there. All right. So bringing it back a little bit, and then I fix it. Because somebody suggests that there's 33. But I know that if you see 33, you're seeing a better thing than me, because guess what? I did not zoom it all the way down because I copy mine a number of times. It changes. See it there. So you might be seeing 33, which is a better vibe, right? But remember, you know, it's what you see is what you see. All right. So if you see 33, it's fine. Suppose you see 33.5, it is still fine. But I think it's 33. So I'm working with this as 33 right there. So this is still 35. And everything is 31, 32, 33, 34, 35, and it goes on. This part is 33 right there. But anybody else get 33 for theirs?
Yes, sir.
Yes, sir.
Very good. Very good.
Yes, sir.
All right. So the principle that we're getting at here, that you pick off your thing, man, and you go for it. Go for it. And you're going to have the graph in your hand to look at in the exam. You won't get a chance to make any mistake. All right? All right. Turn off the mic, I guess. All right. Let me do it. Be careful of your mics, guys. Other persons are here in your background, right? All right, let's go to the next question. It says, We want to determine the probability that a
Sir,
student.
please bring it back down a little, please.
All right. So while you're writing, I'm still reading this, right? It says, determine the probability that a student chose not random took at most, you see, this is the key word here, at most 28 minutes to
Thank
solve.
you, sir.
Yes, at most 28 minutes. Now, if they say at most 28, you want to have words and other words that are synonyms that will allow you to have the same understanding, different words. So you want to interpret at most. What does at most mean? It means less
No more than.
or equal to. It means no more. All of those ideas is the same. You want to have that in your mind. You want to know that so that you will understand where to go for your answer. So you're talking about at maximum 28 going down to nothing. So now we're going to have to find 28 on the minute section and then find the number of students. But remember, your answer must be given as a probability. And probability is already telling you that the answer must be over 200. That is crucial, you know? It's not a solid number, it's a fraction you're going to get, or decimal, or you want to put it in a percentage. But don't think you can give a number bigger than 1 for an answer in a probability question. Remember that. Because you can get carried away with the working out. For example, watch this. 28 minutes we're working on. I'll take up my 28. So I'm going to find 28 now. Watch me. You go to your graph. You take out your ruler. Find your 28. So you know where 28 is by now. So by now we understand that, hey, 25, 26, 27, 28 is right here. So I'm going to follow that 28 line there. And I'm going to take it to the curve. See there? 28. And you see, as it touches it, I stop. And then I'm going to go across to interpret the answer. So by now, everybody should finish. See there? Remember now what the scale was from this side? We're counting by 4. Are this up?
Yes, sir.
So that means this is 64.
Yes, sir.
And then, so you want to understand that because it said at most, that means the answer is under here. So it is from 0 to 64. So the answer is just 64. You understand? So that's it, 64 for this one, straight. This is equal to 64. You get this up? But remember now, you know, it's a 64 here, right? So you put in your 64 over that, and that is an answer. Or you want to break it down. So let me put it to the left because you can break it down a number of ways. So you want to say 64 over 200 because they said probability. They would give it to you because they never said in the lowest term. Or this is 32 over 100. Or this is 16 over 50. Or this is 8 over 25. Or this is 0.32. Or this is 32%. All of those answers, they will take them, every single one. Whichever one you give, you're good to go. And it's because I never gave any specific instruction. I would have written down 64 over 200 and I'm gone. All right? So the moment I write this down, it's done. But all of the others
Bring it
are
up a little bit, please.
answers. I'm listening, speak.
Bring it up a little bit, please.
When they say bring it up, what do you mean? You want to say up here, so,
Yes, sir.
or you want to write off the 33?
Go back up, sir, to the graph part. This is some
Oh, the graph is on, come on, the graph is here. What you want to see? You want me to blow it up for you or what? Are you good?
No, it's okay, sir. It's okay, thanks. You can move
Alright.
on.
All right. All right, guys. So you're looking at it there that you're supposed to be matching back what you're doing along with me, making sure you're comfortable. All right. So here is one. When I was looking at statistics, we were saying that of lately, I realized that they're doing this still. They're missing out things. You see, they're missing out the things. So we spoke about that. We realized that they're missing out things that you can't see. They're missing out things that you're not seeing. All right. But here's a question. The question says, using the cumulative frequency curve, complete the table. But there's no cumulative frequency in the table. So it means that there has to be an understanding of, you should be able to understand that, hey, how are we going to use the cumulative frequency curve to fill out a frequency table? Well, two consecutive cumulative frequency being subtracted give frequency, right? Two consecutive cumulative frequency. In other words, I'm going to change the colors here just for color's sake. I'm going to put the cumulative frequencies here. If I find those two cumulative frequency and subtract them, I will definitely get the frequency when at the spot. And I'm going to have to find the cumulative frequency there and find it there. And when I subtract it, I get it for the last one. Now, let's take a look. The boundaries for these are as follows. Let me look if you need to use the boundaries, maybe. So this is 20.5 here. So I'm going to have to go look for 20.5. So I'm going to make a quick cumulative frequency here. So I'm calling it CF. I am creating this for you. The cumulative frequency for the first one is the same all the time. So it starts off with that same number. All right. So let's go and find the cumulative frequency for 20.5. And then we're going to find out what number goes in this little box. All right. 20.5. So let me clear off some of this stuff off this. 20.5. Here's 20.5. 20.5 is between 20 and 21. And everybody understand that 20.5 is going up here in that blank space based on what the scale is, because each one of those was a 1. So 20.5 come between 20 and 21. So it goes up in a blank space right there. See there? And we are going to need to take that to read off what it is over here. See there? It's a lot of work, but if you understand yourself, no problem. Remember the scaling? This is 36 because it's by 4. So now, watch this. Let me go back to the thing to show you. So you would have seen that 20.5 go up to the curve and go across. It's come across at 36. What I'm saying to you is 36 is in here. Cumulative frequency. So if I have two consecutive cumulative frequencies, see them here? If I subtract, let me put it out here, 36 minus the 12 is going to tell me the cumulative frequency, 24. It's telling me the frequency is 24. So we have to just take note of ideas. They start doing this to you a lot. Two consecutive cumulative frequency being subtracted give the frequency at the last one. Now let's go again. We're going to have to find the cumulative frequency at 40.5 and 50.5 to get these spots. And when we subtract them, we get this. So we're going for 40.5 and 50.5. All right. Let me clear off some of these. just the markings. And yes, these questions, they do take a little time, guys, in terms of you putting together what you have to put together. Sometimes it's not like it's just gonna just blow off. You have to take your time and relax. Time is given to do everything you do. 40.5. So 40.5 is right here. I'm going up. All right. Let me go across. All right, I'm getting that to be 164. So this is 164 here. So when I get 40.5, the cumulative frequency for it is 164. And then I need to go for 50.5. And this look like it is still 96. Based on what I'm seeing, it's gonna be 96 just the same, because the cumulative frequency actually tops off up here too. Hold on. Let me draw down this a little bit more. All right, there it is. So-
Sure.
Yeah, man, I'm listening. Go ahead.
Fee 40.5 when I carry it up in a space, in the pan one, the underline, the in between our space to go over.
It's underlined for me, you know, so do what you have to do. Remember, you know, in the exam, you're going to do you. You hear me?
Yes, sir.
Yeah, man, you're the you. Because for me, it's underlined. Look at mine. See, it's underlined for me. You see mine? Look at mine.
Yes.
It's exactly on it. So, I mean, I am doing me. It's underlined for me. Because you know that sometimes when we print paper, some little shifting go on and you might not do. But in an exam, everybody will have the same thing. So you just do you. So it's the understanding that you're going to get marked for. Don't worry yourself.
Okay.
All right. And then my 50.5 here is coming back in the same, I'm getting back the same 196. Because at that point in time, the curve is like flattening off to it. So it makes sense. All right. So my 50.5 is giving me 196. So now I'm going to have to subtract 164, 196. So let me go back to the table just to show us. So I get 164 here. I get 196 there. And what we're saying is, let me put it over here. The 196 minus 164 will tell you, and this is something that they ask everybody to remember because of lately they're doing it to people. I'll get 32 here when I subtract. That's the frequency. And you know that if you add it up, you see everything works, flow. You want me to show you that it works? We're taking the time, we're learning, we're not stressing anything. Look at this. If we mark up this, hold on, let me just copy this just to show you what I want. We're going to go back to it, so I'll give it a time. Hold on, just to look at this. All right, so I'm putting this here because I want you to see something. For those of us who knows about the cumulative frequency. So if the cumulative frequency was being made beside this, check it out. You would have had, just making up a quick thing, 12 times 12 plus 24 give you that. You understand? And you could see 12 plus the 24 give you the 36. And if you want to skip and come down here, 162 plus the 30 to give you the 96, the 196. And if you add the 196 to the 4, it's going to tell you that the total is 200. Finish. I'm just saying, you're seeing that it's really flowing, right? Even though you don't need to do that for the exam, you just want to have it. But I'm just saying to you, you can see that it's really flowing, right? Even though we pick up the values from the curve, it's still making much sense to the table. All right. Now, having done that, you wouldn't have answered the question because I said complete the table, and you're seeing here. There's an FX. You need to complete that. So this is the X they show you. This is the F column, and that is why they wanted you to do it, because now you're going to have to say 24 times 15.5 and put the answer for it here. Work with me, everybody. Is that 372?
Yes, sir.
Yes, sir.
And down here, it's going to be 32 times 50.5. Hmm?
1616.
Oh, my bad. 45.5. 45.5. I wrote the wrong number, right? You agree? 45.5 should be written. This is this.
1456.
And what you get?
1456.
Thank you very much. 1456. There it is. So they said complete the table here. That's the work. But you see, at 3 marks, you have to work for 3 marks. You understand? They're not just going to give it to you. So it's just some little ideas that you have to know in order to do what you have to do. I don't know if they ask us to find in the next question. All right. So they ask you to complete the table there. So you see the missing things. You follow the thing, look, do what you have to do. And remember, this is only because it's a frequency table here and they gave you cumulative frequency, why you had to use it. So don't just think that this is what's going to come all the time. I don't know, but if I get a frequency table and they want frequency that is missing and they don't give me the data, they will give you a frequency, cumulative frequency graph, and you can use it the way in which we just did. A lot of persons would have skipped the question and left it out. We don't want us to skip. Let's continue. It says, use the information in the table below. Calculate an estimate for the average. Everybody know that average is what we call statistical mean, right? Our mean is statistical average. So the formula for it is the sum of the fx column divided by the sum of the f column all the time. So now you're going to have to do the sum, but we know the sum of the f already. That's frequency. It was 200 you're dealing with. But you need to add up these. Help me add up these. 66 plus 372 plus 1071 plus 2982 plus 1456 plus 222. 6169.
Yes, sir.
All right. Finally now, 6169 divided by 200. I'm getting 30.8. I'll stop at 8. So we're looking at question 6 comes in this section. And question 6 will be a measurement question, like it's a must. Now the measurement questions, the way in which they come of lately, they're not a walkover, but they are just what they are. They are not difficult either, but they are just what they are. All right. So you're gonna have to read and see what they're saying. I can say that much before you could come up with the answers. All right. All right, let's see what this one is saying. It is saying here, in this question, use pi as 22/7. So they're telling you what to do. Sometimes they will say use pi as 3.14. Don't interchange them, use what they want. They have reasons, all right? All right, it says the diagram below shows a scale joint of a running track. It consists of a rectangle and 2 semicircles with diameters LM and MP. All right, and you are told, I guess they're telling you about everything. They said LN is equal to MP, so we're seeing that. This is 49, so that means this is 49 as well. LM and NP is 98, so you're seeing 98. That means this is 98 as well. All right, so you read again. First question. All right, let me bring it back a little so we can. All right. First question says, show that the total length of the running track is this. Now, whenever you see this as show, you know what it is already. So the answer is 350. You just need to understand what it is they want. The running track is to start here, go around. You come all the way around. So they are testing for the concept of perimeter. So it's perimeter they talk. They're just not going to say it, but they're talking perimeter. So when you see this, you're like, oh, but I have some stuff already. I have this and I have this. So it means then I'm missing the curve part. Oh, it's a semicircle. And then you have like, oh, but I have two semicircles of the same dimension. That means I have one circle then, because it's the same dimension, which is true. So all you have to do then is that you need to have 98 plus 98 plus the circumference of a circle. And that will give you the answer. So now you probably just need to work out the circumference. Circumference is equal to 2 pi r, or you can say circumference is equal to pi times diameter. Up to you. I am going to use pi times diameter because I have the diameter. So then circumference is equal to pi 22/7 times the diameter, which is 49. Let me see there. 49 is the diameter. I could say 7 into itself, 1, 7 into that, 7. I'm getting 154. Therefore, the total length is 98 plus 154. I believe this will take it to 350. Let's put it together. Now, you can do it, that's it. But what if you wanted to find the semicircle and then double it? You can do it if you want. But if you understand that since the two semicircles are of the same size, then you could just find one circumference. You're good to go. Any question? All right, so we got that. I guess everybody would have. Yes, go ahead. Is there anybody who did not get this?
Sorry, is that 22/71?
No, man. You have to flow it. I want it. Is Karen? Is that Karen?
Yes, sir.
But why you follow me in the class at the same pace? Meaning,
Yes,
you know why you write something else. It's like when I am on the board, I want it to be there. That's why I wait for people to write. So that you know.
I apologize.
So when me I say, just listen first. You know why you miss nothing? Because when you miss things, you can see other things that were not there. It was actually 22/7. We canceled on the 7 and it become a 1. That's all. So there's a canceling going on. So it will look weird to you if you were not on spot with us. So we actually had 22/7 times 49. But 7 into itself is 1. 7 into this is 7. But if you're not there on spot, you might think it is 7 to 1. Get it now? So you have to make sure that you're there all the time.
Thanks, sir.
All right. So you would see that 350 coming out. Let's see what else they want. Nathan, watch this now. It says Nathan walked a constant rate of 1.4 meters per second, calculate the time it will take him to walk 7 laps around the thing. Everybody know? 7 laps, they said. 1 lap. You see, it's all about interpretation. 1 lap is 350 times 7. Tell me if you know. Agree. 1 lap is 350. Hold on, let me not put the 7 there, my bad. 1 lap is 350 meters. That's 1 lap. We just confirmed that. So 7 laps is that 350 meters times 7. So 7 laps
2,450.
is going to be 2,450 meters. Think about this. You know that this is the distance, right? And he's walking at a certain speed. 1.4 meters for every second. Tell me if you don't agree. That is why the question asks you to work out what? Calculate the time. That's why they said, can you find the time that is going to take to do that? So I'll tell you, there's a direct relationship between distance, speed, and time. Distance is equal to speed times time. So time is equal to distance divided by speed. Time.
Sir,
I'm listening, speak.
could you go back to A because my laptop shut down a while ago.
Yeah, but what it is about A you're looking at?
I didn't get the question. I didn't get the answer.
No, the answer was to prove, man. They told us what the answer was. They were asking us to show. In other words, they were asking us to, yeah, man, they told us that it is 350 already. And they are saying, can you show us that it was 350? So all we did was just to find the circumference of the circle and add it to the 98 and the 98 to see if we get it. And we did add it and we get back that. That's all. Good?
Okay, thank you.
All right, good. And then now, so we are here where 1 lap is 350, 7 lap is 2,450. Fine. Remember that distance, speed, and time linked together. If you want to find the time, it's going to be the distance that you have to travel divided by the speed that you're coming at. So 2,450 divided by 1.4. What you get?
1750. 1750.
All right, so that is the time that he's going to take. This man will take 1,750 seconds to do that. Yep. Yes, Wilson. That's the amount, that's the time. 2 marks for it. So that's the time he'll take. So remember the magic triangle. Distance at the top is equal to speed. So if you put your finger over anyone, you can find the next one. So it means if I want to find T, if I put my finger over T, it is telling me that D over S. If I want to find the speed, I thought put my finger over the S, it's telling me that the D over the T. And if I want to find the D, which is distance, put your finger over it, and it's telling you that it is speed times time. So you can write down your little magic triangle for it and utilize it to help you, all right? All right, so we still have more stuff to do. They said Tafari runs 1 lap of the track in 68 seconds. You have to make a note of Tafari's speed. Determine the number of laps Tafari can complete in 1 hour running at that same speed. You hear that? Look at you see, you're looking at how they're putting the questions. No, it's not a big question, but you have to read. Let me go at it again. It says that Tafari runs 1 lap in 68 seconds. Determine the number of laps Tafari can run in 1 hour. Oh, So we're gonna have to link hour to seconds. You have to. If you don't realize that you need to convert that hour to seconds, you're in problem. First, we want to convert 1 hour to seconds. We need to do that. So 1 hour times 60. All right, and that is sorry, and that's gonna give you 60 minutes, and then multiply it by 60, and you turn it into seconds. So 60 times 60, turn it into 3,600 seconds.
$3,600.
3,600 seconds. Good? No, that's not the answer. No. We are just saying to you 1 hour is 3,600 seconds. And if he's going to do 1 lap every 68 seconds, you can see that you can figure out the number of laps is going to equal to 3,600 divided by 68. Because every 68 seconds is 1 lap back. And he's going to be running for 3,600. Now I want him to make the right decision. You know? Anybody want to tell me what the answer for the question is?
52.9.
53, sir.
You see that?
52 laps.
52 laps,
Very,
sir.
all right. Very good that everybody's talking. Now you're going to have to read the question within a context. Determine the number of laps. This is not a joke thing, you know. Now, will he get more than an hour? Will he get more than 3,600 seconds? Yes or no? You're going to have to say no. So he would have completed 52 laps. Will he have enough time to finish the next lap? Yes or no?
No, sir.
No, sir.
What do you think the answer is?
52.
Exactly. So here on this question, catch the people them now. Everybody has said, oh, make a round it off, man. Yes, man. This have nothing to do with that. Because the question never said round up to the nearest lap. If the question had said round up to the nearest lap, 53 is the answer. But the question says, how many laps can you do in that time? You better be real with it. He only can do 56, 52 laps. He was almost there to finish the next, and then time run out. So he did not complete the next. So he did 52 laps, and this is what they want for the answer. 1 mark to put that, and 1 mark for the working out. So anybody who put anything else, you would have lost 1 mark and got 1, because you have to put 52. So you would have gotten 1 mark to reach here, and you get the next mark to tell them so that this is how they mark the question. So the last one is showing you that you really understand context and the marking for that differently. So it's not about just working up the numbers and running that, right? 52 laps was the good answer. Very good, very good, very good. Now it gets deeper now. Look at this question. You see the question them get deep? Michelle, question them deep. It says here that Nathan completes running 1 lap up the track every. This is Nathan. I'm just going to put Nate, TH. Nathan complete his lap in what? 72 seconds. So he's taking a little longer than Tafari, as you could see. Tafari, watch this now. Tafari and Nathan start running at the same time from L. See that? They're going to start at the same place. Each completed a number of laps. So they run different amount of laps. Calculate the least number of laps that each will complete before they both meet at the same place. Let me tell you what's going on. So I'm going to just run back to the track. We want some context. Tafari and Nathan are going to start running now, right? Tafari and Nathan will start running right here. So the line is here. So this is Tafari, this is Nathan. They're going to run from that spot. Obviously, Tafari is complete, will go faster because Tafari will take 68 seconds to finish 1 lap. Nathan will take 72. So over time, Tafari is going to increase and be a little bit in front of it. You know that. But they'll be running and running for a while. So what we're going to notice is that they are not going to be running together. But the question is saying, after how long will both of them pass each other right here if they're running at that same pace? Now, what concept are they edging at? You see, whenever you're doing math and you see you're comparing two set of numbers, see Tafari number here, 68. See Nathan number here, 72. And you see they said calculate the least. Anybody want to tell me what maths concept come to your mind from you say the least number of lap? The least. You're comparing two numbers and you want to know the least. Anybody?
Lowest common multiple.
Exactly. Exactly. So if you're not going back to your little grade 6 thing, you know, you're in problem in your CSEC exam, you know. Because if you think it is too high, problem. Lowest common multiple you want. You want to know at what time will 72 and 68 be the same again. They're not going to be the same. In other words, then, what you want to do is to find the LCM for both. And when you find the LCM for both, you're going to use it to solve the problem. Because, listen, calculate the least number of laps that each will complete before they are both at the same point again. See there? So there's the amount of laps you need. But you see, in order to know the amount of laps, you're going to have to find a time that matches with both of them clashing. So LCM of 68 and 72. Anybody want to tell me quickly what they think? 68 and 72.
68 is 2 times 2 times 17.
Okay, you're doing it that way. All right, you're doing it. All right. There are many ways you could do it, guys. I will not try to show you all the ways, but what I'll say to you is this. Let me say this to you. What you want to do, you want to find the smallest number that both of these could go into without a remainder. You can do many things to explore it on that line. So, one of the things you could do is to, I'm going to give you the weirdest one. You can multiply both of them. And you notice I'm saying the weirdest one. You can multiply both of them. That's not the answer, but it is there where you could break it down until you get the answer. If you multiply both of them, it's going to give you a number that you could break it down until you get the answer. So you could divide this by 2 again until you get the answer. Or you could find a number that could go into R. Better yet, if you multiply both of them, if you find the biggest number that can go into that and divide it by this, it tells you the answer right now. So if you multiply the two numbers, you get a number. So to find the LCM is like if you find the biggest number that can go into 68 and 72, and I think that number is 4. 4 can go into 68 and 72. There's no other number bigger than that that will work. So if you divide this by 4, I think you're going to get the answer. And that's one way to get it.
We take away those, sir. Take away 68 from 72.
Subtraction won't work, you know. What do you mean by? Oh, it's a buck up that, you know. Michelle, that is a buck up here.
Oh, yes.
Yes,
right.
man. Yes, man. That's a buck up. Because if the number turns 67 and you subtract it, that's not going to work. You get me?
That's
all right. It's a good buck up. It's a good buck up. In other words, all right. So if you divide this by 4, this is the number. This is saying that after 1,224 seconds, they will both be there. This amount of seconds. Let me do it another way, please. What you can do is to break down these. I'm giving another way. Let me give another way, please. Let me, because, all right. But there's no easy way to find these when the numbers get bigger. There is a thing called prime factor, where you can keep dividing by the simplest, the lowest prime number, in this case, 2. I would say 2 times 34 give me 68. 2 is a prime number. That means this one is finished because there's no other number that can go into that but itself. So that means that is part of my thing that I'm going to utilize, right? Then you could break this and you said, oh, but this is 2 times 17. And then you say, oh, but this stop because 2 is prime. And hold on, why is this not touching my mark? Hold on, guys. 2 is prime, 17 is prime. So that means you're finished here. That means 2 times 2 times 17 gives 68. I'm going to show you how you can use prime numbers to help. So this is called prime factorization. Quickly, I want to go faster, right? Now you want to break down your 70. 2 times what give you 70? You're going to say what, 36? And then the 2 would have been a prime. Somebody mic open. Could you close it? I'm keep hearing whatever. Close your mic, everybody. All right, not hearing. Let me just do it quickly. Thank you. Just did it. All right, let's go. So 2 times what? 18. The 2 is at the end of the road again. And I'm going to go again with 2. 2 times 9.
9.
And then I can go 3 times 3. So this is suggesting that 2 times 2 times 2 times 3 times 3 works. All right, let's look if we're making a mistake there. All right. All right, so then we are suggesting that to find the number, right? To find the number that you want, you actually can do this. And this is kind of a little weird case right now, right? So this is a special way that you can use to help you when you want to find the answer. The numbers that are coming out are as follows. Look, so this is 1, and this is the next set. So I'm just giving you another option. I'm not telling you to do this. Yeah, man, you see them works 2 years again. You see this at Egypt.
So my daughter tell me if you do it a while ago, you know.
And this is called prime factorization. So what you're going to do now is you're going to make a number from these, but you're going to pick the, all right, let me say these, we're talking about 2, 3, and 17. Everybody agree that it is either 2 or 3 or 17 is up here right now? Be honest. Look, 2, 3, or 17.
Yes,
So you're going to pick the one with the most in it each time. So in other words then, this win in terms of 2, because I'm seeing 3 over 2 alone. So the 3 2s win for the 2s. That's what we're doing. 2 times 2 times 2 win over 2 times 2. It's more. Now, when you look, you realize that this is going to win because there is no 3 to compete. So 3 times 3 win. There is no 17 to compete, so 17 win. I am telling you, if you multiply 2 times 2 times 2 times 3 times 3 times 17, you will still get back this number that I found just now. Check it. It worked. It's called prime factorization, way of finding LCM. Prime numbers find LCM for you. I don't want to spend more time on it, guys. Watch over the recording and you can do some more research. All right. So the number is 1,224 as the LCM. And you can get, so that's the number that we want to use. Let's go back to the paper. So we have the number already. So I'm not going to do the other way here. All right. So here is the number that you're going to use. You can watch over the recording and spend some time. That number. Now, in order to know the number of laps, guys, is the question you have to how much lap. So you're going to say Tafari. Look, can I say T for Tafari? Tafari is going to complete 1,200 and that. Divide by 68. Talk to me. How many laps Tafari would have to complete? 18. Nate, 1,224 seconds by 17. This question is simply saying that this is by the time Tafari do 18 lap and Nate the 17, 2 of them meet back at M. Remember, that's what it is saying. And that will happen 1,224 seconds after them start. This is what they want to give you the 3 marks for. It's not hard. but you can see it has reasoning in it. Everybody see what I want? Not hard, but it has reasoning in it. Very recent question. This is a 2023 measurement question. That's what they just said. All right.
Hold on, sir. Put it back, please.
All right. Here it is. There it is.
Hold on, sir. Don't move it just yet.
All right. Give me the instruction when to move.
You can go now.
All right. Thank you. All right. Let's look at the next question now. So you see, at number 4, if they're not sending coordinate geometry, they can send this. This is why sometimes maths is a lot of work, because they have options. If they don't feel like sending this, they can send another thing. All right, let's go. Oh, it says the function f, music. I'm hearing music in the background. Everybody mute your mic. Everybody be conscious of the background now. Everybody mute up. Everybody mute. I don't want to look to see who it is. Thank you. All right. It says the function f and g are defined as follows. F of x is equal to 5x plus 7. G of x is equal to 3x minus 1. For the functions given above, we want to determine g of 1/3. Again, g of 1/3 will be done using the g function. So you want to take the g function here. Let me write it back. And you're going to put 1/3 where x is, because the only place you can substitute is where x is. Allow the math to work as it is. So this is 3 times x, so it's going to be 3 times 1/3. Then you take 1. 3 means 3 over 1, you know, so you could see what's going on right there. You could see that it's canceling itself, right? So basically, we're getting 1 minus 1, we're getting 0. Everybody got 0 right there?
Yes, sir.
All right. So we get 0 for that. So the next one, then they're asking you to do the inverse, which is this. We want to do the inverse of f of -3.
Sir?
So yes, I'm listening. Go ahead.
Oh, never mind. I just wanted to finish right now. Let's see now.
All right. F of x is 5x plus 7. Right? Now, in order to do the inverse of f of -3, you need to do this first. You need to find the inverse of f of x. And then all you're going to do is to put -3 here when you're done. So we're going to take this regular function. Wow. And find the inverse of it first. Remember how the inverse goes. I normally said to you, you can just tell them, so let f of x equal y, okay? Because you're about to use a y in the math here. So you're going to use it y, because inverse is about switching x and y. So you want to have the y in it. So y is equal to 5x plus 7. Now you want to switch x and y. So you know that there's a switch. So you're going to have x is equal to 5y plus 7. Then transpose for the new y. So then, regular transposing skills, you subtract 7. You divide by 5, divide by 5. So then I could say to you now that the inverse of the f function is x minus 7 over 5. But remember, that's not the answer, because they want you to put -3 in that function. But we were saying that in order to do it, we need to have the function first. So now that we have the function, so all we're going to do here is to do it. So let me just mark off a part here. Right here. We want to do the inverse of the -3. Yeah. So here it is. All you're going to do is to put -3 where the x is in that function and work. The answer is -2. Good going, Stone. So guys, these sort of stuff, it just has a little procedural thing to it where you want to make sure that, because you can't jump the gun. In order to do it, we're going to have to find what that is. So we take our time, find it, and then we just substitute. Don't rush it. All the questions are what they are. You have to look at it and then do what you have to. Am I allowed to push up the screen a little bit? Not far, maybe there. Or even here. All right. I'm just reading, and then by the time I finish reading, I'm going to bring the screen up more. It says, carry back. All right. All right, go ahead. You have to give me the go ahead.
Yes, sir.
Is she giving me the go ahead, or she's responding?
Yes, sir. Go.
All right, thank you. It says the function f is defined as, and guys, this is the same reading, so don't watch the fancy layout. It is still saying f of x is equal to 3 minus 2x. It is the same thing here. So don't let the fancy thing trick you. That's what it is saying, right? That's just another notation. Now it says the diagram below shows the mapping diagram of the f function determining the value of a. All right. Now you look for yourself. Determine the value of a. They're testing to see if you understand. This is saying that it's when 0 was placed here, you work it out and get 3. This when 1 was placed here, you work it out and get 1. So what you need to do is to put in -1 and tell what a is. So basically, f of -1 you need to find. You want to put -1 where x is and see what you get. A is equal to 5.
Sir,
I'm listening, go ahead.
I'm logging into another device so that you should know. And I'm going to come from this one.
All right, cool.
It won't have my name. I don't think it have my name.
That's fine. No, open the class, so you'll come in automatically. All right. So A is equal to 5. Everybody, good with that?
Yes,
so if
sir.
I want, I could put it on the line here for you. See there?
Sir, where's that -1? Oh,
It's a
okay,
question.
from x.
Yes, because that is why you substitute. Remember, I know, because they're not going to tell you, but you are to know that it's these values you plug in the function to get these over here. That's a natural flow. You plug in the values for x in the function and it tells you what the f of x value is. All right?
Oh, yes, sir.
All right, good, good, good. All right, let's see what else. All right, more question on the same. It's from the same thing. It says
Sir,
here
can
determine.
go back a little, please. Let me just write
Determine
it.
what you're writing off this.
No, the one on the line, the equation on the line.
Oh, it's the same thing, you know, me just write it back here. So.
Oh, okay.
Yeah, man, you don't have to write it, guys. I just wrote it back. All right? All right, good. All right, it says now, determining in their simplest form, very important, expressions for the inverse of the f function there. And okay, these. All right, let's go for them. Let's go back for, can somebody tell me what it is? Oh, 3 minus 2, 2x, that's it. All right, so let me write this. So the f function, f of x, is 3 minus 2x. And they want the inverse of it. Same procedure. You need to switch, start off with this, always. Then you switch x and y. And then now you start transposing so the y is alone. So you want to get rid of that so that it appears on the other side. And then you divide by your -2 so that the y is alone. So you would end up with this. But nobody asks you about y, so you need to finally conclude that this. You're fine. So you just need to write the last. So every time you reach this part, go ahead, I'm listening.
Never mind, sir.
Okay. So I was saying that every time you reach that part, remember what the question is about. Write it back. Give them what they want. They ask us for it. Give me the go ahead. Waiting on the go ahead to move up the screen. We're okay?
Yes, sir.
This one now is a little problematic, but I have pointed this out to us when we were actually in class. We were saying that, hey, when you see the square of a function, it does not mean to multiply the function by itself like you do in algebra. Remember, the square of f of x really means that f will go into f. That's what it means, right? So it means that f goes into f. You need to know that that's what it means. So then you start off your function with your f, and you're going to take up the same f.
Sir, can you please scroll up to the previous one?
All of it are right there.
All of it, please, sir.
Huh?
Can you scroll up to all of it? Thank you, sir. Thanks, sir. I have it.
All right, good. All right, so for this one, I was saying to you that the important thing to note is this part. This means this, the meaning of it. It does not mean to multiply it by itself. So you see, anybody who run ahead and do this, that is algebra, that's not functions. That's algebra you're doing right there, not function. You remember even in matrices, you don't do that because there's a different context for everything. So in the world of functions, this is the square of a function. The function goes into itself. So now here is the function. Remember, the only place you can manipulate is where the x is. Is it right now? I'm going to have to open a bracket. I'm going to put the function in itself. Here's the function again. So look at what I'm doing. Just take a look quickly. That's it. The f function goes inside of itself. But there's only one place that you can go. You only can go where the x is. So you would have written back everything and then place the entire function where the x is. Then you carry out your math. 3 is okay. Now you're going to have to distribute. See that? So the whole game changed now. -6, +4 with an x. Then we simplify. All right. So now this becomes -3 with a 4x. Or you could have written 4x with a -3. This is that. Tell me if you're all right. So as the function goes into itself. But you have to remember that there is only one place that you could put something, right? And it is where the x is. All right, let's go for the next one. Now look at this other one here. This one says here, you're doing f of the inverse of f of 2. So what does this mean? This means that, let us say, did we have the inverse before? Let me look if we find it. Yeah, we have it. All right. So we have the inverse. So we're good. They had allowed us to find certain things. So let me go back for it. Can I go back for this first? Can I just write the f function here first? The function is this. And then allow me to write the inverse also. What was it again? It was over -2. What was it, DJ?
X negative, X
-3.
minus 2.
X with a -3, not true? Was that it?
Yes, sir.
All right, good. So now that you have those, they're asking about them here. See there? But remember though, you see, whenever you're doing a composite function and there's a number in it and you're doing a number of things, remember composite functions, you can approach it go that way. Which means I can find this part now. I say anything I get for it, I'm going to put it in this. Anything at all. So we're working it going back way. So I'm going to find the inverse of f of -2 first. I'm going to get a number, and that number going to move forward and go in the f function, and we finish. So let us start off with finding this. So having this function here, let me write it back. We are going to first find what's at the back, which means to put -2 here. See there? So I'm putting the -2, which is right here. The other -2 was already there. So we are just changing out there. This goes right there. So we end up with -5 over -2, which is at the end becomes +5/2. So this piece here, this, hold on, let me write it clearly. All right, let me move up the screen. I think, yes, I have enough space there. So this is 5/2 or 2.5, whichever way you want to look at it. So now that you have this, you can go forward with it now to the f function. So let me clear back this up. See here? We have just found this piece. And if I should write a value for it, it is 5/2. So the 5/2 will now come forward in the f function. That's all. Here's the f function. Now I want to do f of 5/2 or f of 2.5. See there? So now, luckily something is here to cancel easily. This cancel one, this cancel one. So you know what I'm left with? 3 minus 5. And I'm left with -2. So I want to conclude though for the exam. Because the exam never asked me for this, you know. I wasn't asked for this. But based on how we work the problem, we end up with that. So I'm going to conclude and say, hey, you see f of the inverse of f of -2, it gave me -2. So just double check, as long as there is no error, we're good to go. So basically, while people are writing, I'm just gonna explain something here. If we have G of H of M of T of X of 2, doesn't matter. This is saying that I need to find this first, and any number that I get, I'll put it in this one. I say any number that I get after that, I put it in this one. I say any number I get after that, I put that number in this one. I say any number I get after that, I put it in this one, and I'm done. It's the same principle. It doesn't matter, even if they line up 10 of them, start at the back. The moment you're able to get a number, take that, find it, and keep coming forward with that value. Keep changing, no problem, it doesn't matter. And whatever you get at the end is your final thing. All right, guys? So that's the principle here. That's what we did. All right, let's see what else is there.
So can you go for 1 second, please?
All right.
Okay, thank you.
All right. All right, this, what is this one now? Hold on. Okay. Maybe I have to, let's say if I have to bring this to the next board. Undergrade label, that. One more, all right. Stats. All right, let me see what this is saying. I'm thinking if I have to bring this one to the next board, if I have to draw long lines, if I want it to look neat, let's see. It says using a ruler, it says draw the lines using a ruler.
Sir,
Yes.
can you please go over the one that you were at, state the value of f inverse, because I got kicked off.
Oh, Mom, I was just saying that when we're working a problem like this, you go, all right, you go, when you're working a problem, it's a compound, composite function like this. And it's not about the inverse, you know, it's just about, I'm just saying, if you're doing a composite function, that a value involved, there's a value here. We're suggesting that you work it backwards. You would have found this first, just like when you do composite function. And then whatever you get from this goes forward in the other function and you work it. All right, so that's what you do with composite functions.
Okay, so can you go to the answer, please, so I can...
So what we were suggesting here was that we were just looking at just the workout of how the things work out. So we had the two functions already, all right? And so we did this piece here, the back piece here, to get this. And then whatever we got, we put it in the front function to come back to that.
Okay, sir.
So then I was saying to everybody here, it doesn't matter how long the thing is. We are looking at an idea that If this is what you have to do, find the back piece. Whatever you get comes here. Whatever you get again comes here. Whatever you get again. So that's just the principle. You start from the back going that way. That's just the idea that it goes like that. All right. Let me see if we could finish this in the time. I don't know how many questions underneath for this. It says using a ruler, draw the line. Oh, draw the line where x is equal to a half. Y is equal to, oh, so I can't do it here. I have to do it on the other board for it to look good. All right, let me copy this, please. Minimize some of the spacing so I can get a big diagram over there without additional. Oh, wrong thing. There it is. All right, let's go for it now. Here on the board, put it on. All right, let me pull it like this. All right, that could work. All right, here goes. They're asking us to draw. So with your ruler, they're saying draw the line. So first, draw the line where x is a half. All right, based on the scale, you would agree that x is a half right there. Based on the scale, everybody? You're looking at your diagram, x is a half
Yes,
there.
sir.
Yes,
So they said to draw that line, you take out your ruler and you follow this line, just brighten the line. The line is already there, you know, you just brighten it, see there? All right, I might put it in a different color, all right? Red. See the line there? So you just brighten the line, x is a half. See, I normally label it, x equal to a half. That. So that's that line. Everybody has seen that line?
yes, sir. Wonderful.
And they said again, draw the next one, y equal x. Anybody remember the last class we're talking about y equal x and so? Y equal x is a line where x and y would have the same value as a coordinate, like 1, 1, 0, 0, 2, 2, 3, 3. They're all on a special line. The line is called y equal x. So that's the line right there. So all you're going to do is to take your ruler, you're going to brighten it. That's what they wanted to do right now. So hold on, let me take this off. Start right here, here. Sorry, I think I moved the point instead. All right, so I'm going to draw my y equal x. All right, I think. All right, see my line there, y equal x. So let me put on it y equal x. On y equal x, guys, the coordinates are the same. You have to remember that, you know, the coordinates are the same. Now, this line that you're supposed to draw, x plus y equal 5. One of the beautiful thing about lines is that they tell no lie. If you can find any number where the x value plus the y value give 5, that's a coordinate on the line, you know? Would you believe that? The line is x plus y equal 5. Watch this. On that line, you will find 1 and 4. You know why? Because 1 plus 4 gives 5. On that same line, you can find 3 and 2. You know why? Because 3 plus 2 equal 5. On that same line, you can find 2 and 3. You know why? Because 2 plus 3 still give 5. And if you never knew, this is one of the most beautiful things about these things. It works. Just as I would say, x plus y equal 5. If I find an x value and a y value that had to give 5, it is on the line. And look how the line look like it line up already. Watch this. And I'm going to just draw the line and you could see that everything on it will add to give 5. Watch. This is no joke. Look for yourself. All right, let me put it back in the same color red. See there? Look for yourself. I'm going to blow it up for you. X plus y equal 5. Look for yourself. Every coordinate says 5. Even the ones that you never did. They actually said 5. Look. So I could mark some of them and we could move after that. Right here is where 4 meet 1. See there? Right here is where 3.5 meet 1.5. It still works. 3.5, 1.5. That is still 5. I'm just saying. Right here is where 5 meets 0. 0 plus 5 is still 5. All right, I'm just saying. So why am I highlighting it? Because I don't want you to feel weird with these sort of stuff. These interpretations I'm giving you are kind of unique. A lot of people really don't know that it really works like that. All right? All right. So let's check this out. So you did that. You would have done that for someone. Let me see what the question says here. And I know it's 2 o'clock, so you're going to have to give me another 10 minutes again, please. Oh, the question is not here. Let me go back to the question. All right, let me blow up this, guys, so we could see what they want. So they asked us to draw that. So you would have done that. It's 3 marks to give you. It's 1 per line. 1 for each line. 3 marks. So let's go for the question. Go ahead, I'm listening.
Before we move on, sir, how you get the line to be y equal x, sir?
No, I know we get the line, you know. Read the question. Look. Oh, you mean how I draw the line y equal x? That's what I mean? Because they asked us to do these. See them there?
I have not been taught this topic yet, so I'm not sure.
Oh, all right, let me ask you a question. Are you asking me how did I get the line y equal x?
Yes, sir.
Yeah, man. So let me go back to it. I said it in there, but I think you're probably not listening. When the thing says y equal x, I'm kind of showing you a real idea that a lot of people overlook. This is telling you that every coordinate, the y value is the x value. That's what it means. I am just giving you a heads up of an important idea of the equation of line. They tell the truth. So if the line says it is called y equal x, it is telling you that every point on that line, the x value and the y value is twin. So you only need to find 2 of them and draw the line. Does that work for you?
Yes, sir.
So I was saying to the class, look, see 1 here, 1 meet 1 on that line, 2 meet 2 on the line, 3 meet 3, 4 meets 4, 5 meets 5. And if you check it, half meets half on the line, 1.5 meet 1.5 on the line, 2.5 meet 2.5 on the line. The line is called y equal x. Anything you pick for y, pick it for x, and it is on the line. You get what I mean now?
Yes, sir.
Yeah, man, that line is, yeah, man. And every other line, they are unique like that, but I can't spend the time to discuss those. But grab that and run with it. It works. So you just draw the line and you get 3 marks. Let's see what they're asking now. Watch this. So you're going to have to pay attention now. This is called linear programming, where you can use the lines to respond to certain things. It says on the grid, labeled as R, no, on the grid, label as R, the region where this, and this, all right, all agree. Now, this one is coming from where, let me show you what I'm, let me write it for you. Let me write on this first and then I go back. Where's the x is greater than or equal to 1/2, it's coming from where x is equal to 1/2. That's the line that you'll use to help you to understand. This one that says y is greater than or equal to x is coming from y equal to x. This one is, you see them look familiar? Less than or equal to 5 is coming from where? So for every equation of a line, there is an inequality that is there depending on whatever you do. So this one is saying that it's when you find the line, I am thinking of x values greater than 1/2. That's what it means, you know. And you know what this one is saying? It's when you find this line, I am thinking of y values bigger than x. And this last one here is saying that it's when you add up x plus y, please let it be less than 5. So I'm going to help you to understand what that means. All right? Watch this. As soon let it go. Look what it means. So we can switch to look at them quickly. See? So we can switch. Let's look at the first one that says x is greater than a half. Now, x greater than a half. But why you tell me, true or false? Would you agree that the numbers going this way is greater than a half? Yes or no?
Yes, sir.
So it is
Yes.
straightforward enough. So this line is saying x greater than a half is pointing that way. Tell me if you agree. Tell me.
Yes, sir.
Yeah, man. And we won't be able to tell everything, but we can tell the direction it is pointing in. We know it's not behind the line, because behind the line it's going towards 0 and negative numbers that are less than a half. But we want to look on the concept, the idea where it is greater than a half. So we're looking in that direction. Now let us look at the next one. This one says y greater than. Guys, greater than. You see, when your line is slant, whenever you're dealing with a slant line, greater than is above the line. Let me say it. A slant line, greater than means above the line, less than is under the line. That kind of makes sense? If the line is the margin, if you're flying above the line, aren't you greater than it? And if you have a marker and you're flying below it, aren't you less than it? Yes. So then, this one that says y greater than x. Oh, this one is saying that, can you fly above the line for me? The line y equal x, can you fly above? Everybody can see the point to make it above, going that way. Yeah, man. Don't rush it in, but remember, it's just gonna be as simple as this. The final one you want to look at now, look what it says. X plus y less than 5. Everybody agrees on less than it says? Less than 5. So less than would mean that this one is saying that, hey, below the line. So see the line here, you're gonna point below. Less than is below the line. Now, let's answer the question. What the question wanted was one region that all of them agree on. Look for
In the
yourself.
triangle.
Exactly. Is one place they all agree. See it here? This is the only place they agree. All three, they're pointing in this region. And this is where you would have write R. I'm going to go back to the question for you to see the point I'm making. This is R. This is where, look at the three different arrows pointing here. There's nowhere else where you'll see 3. You might see 2, you might see 1, but you'll never see 3 except for this spot, because this is the only region that works for all of them. They have their own conditions, their own problems, and this is where they all agree and they could work. Believe me, right there. That is where you put your R. Look at the question. It says, on the grid, label as R the region where X is greater than half, Y is greater than that, X is lesser than that. And I'm saying to you, and you notice it's a 1 mark question. It's nothing big really, you know, but you would have had the graph already. They get 3 marks to draw the lines already. And now they're giving you another mark to understand where all of them saying the same thing.